Righteous. Nice. Hello again. From the 403 to the HAZ, Mr. Nelson here. Doing my best to get as many videos out here as I can before kids go on break, before my babies, before my Hazelton darlings go on break here, because I don't know if there's going to be any school to come back to in a couple weeks because of this coronavirus. So just trying to get some stuff out there so that they can do some practice on our new surface area and volume unit while I'm gone, while we're separated briefly. I'm looking for my pens as always. Where are they? Like, where do I even put them? I just have them. I didn't even go anywhere. I literally didn't go anywhere. Okay. Screw it, we'll do it live. We'll do it live here. Okay, we are talking about composite shapes. These are just shapes that are combinations of multiple shapes. If you can understand how to work with the individual shapes, this stuff is a breeze. It really is. There's a couple little small things that you have to be cognizant of, be aware of, but it's not bad. So here's some examples of some composite shapes. I could have something kind of like a, oh, that's terrible. Okay, I know how to do this. I can do this. Okay, so like I've got a rectangular prism, and then let's say that this prism has a rectangular pyramid. A pyramid with a rectangular bottom, okay? So that's one kind of composite shape, and you know, like, that's kind of the stuff you'll see. Maybe you'll see something like, you've got a cylinder, and you know, this is the pencil shape you see very often, and it's got a cone at the top, and at the back it's got a hemisphere. Okay, you're supposed to calculate the, well, this should be dotted too because this is not visible. Okay, so you're going to calculate the volume and the surface area of this shape, and obviously you're going to not include the connections here for the surface area because that's not outer surface area, it's not on the surface. What else do we see? We see, like, have we seen much more? Like, I'm trying to think of combinations, we have to look at them. We can do, okay, hey, here's another shape. We can do, some shape like this. So we have a hemisphere, and it's attached to a cone. Okay, like, honestly, that's I think as much as you're really going to see. Or like, you know, we're going to see some variations of these. So all we need to do when we're working with these shapes, the biggest thing is to identify what our shapes are made up of. So this one, I would say, okay, this is a rectangular prism, and they're going to give me the dimensions, obviously. And I also have a square or rectangular pyramid. And I have the formulas for all these things, so they would give me everything. Now, sometimes they're going to be sneaky about the way they give me information. Like, for example, they could give me the radius of this cone, and I'd have to recognize that that radius is going to be the same radius here as is going to be the same radius here, right? Like, these are just little tricks. I just have to be aware of what's going on. I have to think a little, ever so slightly. It's hard without problems in front of me to tell you what you're going to run into, but here we go. Here I'd have to recognize that I've got a hemisphere, a half sphere, hemi, the old hemi. I've got a cylinder, and I've got a cone. And then here I have a hemisphere, got the old hemi, and a cone. Now the volume for composite shapes is quite straightforward. It's just the total volume. Volume of my rectangular prism, volume of my pyramid, volume of my half sphere, volume of my cylinder, volume of my cone, and then I've got volume of my hemisphere, volume of my cone. It's the surface area that I have to kind of know what I'm doing, because when I'm calculating the surface area for this shape, I have to recognize that this connection where they meet each other, that's not an outer surface area point. So essentially, I'm going to have this surface, we'll call this surface 1, and there's going to be two surface 1s. And then I'm going to have this surface here, which is going to have an opposite back here. So I'm going to have two of those, so we'll call that surface 2, which is just a square. And then I'm only going to have one surface base, so plus 1, so my surface 3, my base, we'll call that. Right? So this is going to be the same as that, area-wise, that's the same as that, that's the same as that. So that's what I'd have to calculate for my rectangular prism. And then for my pyramid at the top, all I'm going to do is the surface area of my 4 triangular sides. Knowing that, so they give me the dimensions. They give me this to here, or this to here, right? They might give me the height of the whole thing, okay? And then maybe the height up to here, and I'd have to recognize that to get the height of my pyramid, I'm going to have to subtract this height, or this height from this height. Okay? I don't even know if I'm going to do any problem. I think I'm just going to talk about these with you for now, because the videos have all the information on calculating the different parts. So I'm not going to, you know, I got to be efficient here because it takes me 5 times to make the same video. That's a rant from my previous video. I must be getting comfortable because I'm talking a lot. So if I was to do this one, I would do the volume of that, the volume of that, the volume of that. Now if I was calculating the surface area, I would recognize that for my cone, I'm going to ignore the base. I'm not going to include the base. I'm just going to include this part, which is, I believe, 2 pi times r times my slant height, that. For the area, right? That's going to be that area. The cylinder is just going to be the area of the side of my cylinder, which is my circumference. So it's my 2 pi r times my length or my height or length. Because I'm not including the base of both the top and the bottom of my cylinder because it's hidden. And then again, we've talked about this before in my sphere video. Then we would just calculate the area of half a sphere. And I wouldn't have to add the area of my base here because again, it's hidden. And here, it's the same thing. I'm going to do the area, for the volume, it's the volume of half a hemisphere, and then the volume of a cone. If you don't know how to calculate, you know, the various parts, just watch those videos on these, because if I go into it, it's just going to be another 30-minute video, and neither of us needs that. So when I'm calculating the area, which is going to be the troublesome area, I just have to recognize that I am not going to include the area of the base for my cone. So the area for the top of this shape is just going to be the area of the outside of the cone, or like what I mean is this part, which goes around. And that's going to be my diameter, 2 pi r, or pi d, times my height. And my height is my height from here to here. Now they might hide the height, you know, by giving me this total height and giving me the radius here. And so here's one of the tricks they might do to make it, because you're like, oh, it's not there, I don't have my units. So say they gave you the radius here, okay, and they gave you the total height of this shape, okay? And you're trying to do your, sorry, this would be slant. So you're trying to do your volume. So we're going back to volume, right? And you're like, well, I don't know how tall my cone is. I know the radius of my half sphere, but I don't know how tall my cone is to calculate that. But I do know this height. Well, I could recognize that this radius is also the same as this radius here. So I could, to find the height of my cone, I could just subtract my radius from my total height. Okay, so sometimes they hide the dimensions in ways like that make you have to think a little bit more. But you have to trust that it's going to be there. So to calculate the total area, I'd have the area of the outside of my cone, which is 2 pi times radius times s, or the circumference times my slant. Oh, pi rs. Oh, woe is me. Oh, sorry guys. The area of the outside of my, that's wrong. Area of the outside of my cone is pi times r times the slant height. The slant height is this, which is not to be confused with the height here. This actually forms a right angle triangle. So then the area of the outside of my sphere here, area of my hemi shell, is just going to be 1/2 my area of a sphere, or area of my hemisphere is 1/2 times 4 pi r squared. So then to calculate the total outside area, which does not include the connection point, my total surface area, which I'll call wow, which I'll call surface area, is equal to the area of the outside of my cone. So the area of the outside of my cone, I'll just call that area cone, outside, out, plus area of my hemisphere shell, my half shell. Turtle's in a half shell, turtle tower. So I'm just going to calculate the area of the cone, the outside of my cone, which is pi rs, and then I'm going to add that. And if I simplify, it will be pi rs plus 1/2 times 4 is 2 pi r squared. If I plug all that into a calculator, I'll get the right answer. That, I think, is all I really need to. I'm not going to do the math for you because you can do that. If you put in a comment and ask nicely, I will, but until then, I think this is enough. Thank you very much. You guys have a great spring break. Mr. Nelson loves you.